explain a projectile problem labeled Medieval Siege. You live in the kingdom of Wolkit. You're trying to attack your biggest rival, the kingdom of Holy Cross. Wolkit is known for having great catapults, but Holy Cross has a great defensive wall to defend against these catapults. Along with the wall, Holy Cross has a 45-meter wide moat. And so your rock has to travel across the 45 meters and over Holy Cross's wall. And the Wolkit catapults can only launch a rock with an initial velocity of 25 meters per second at a maximum angle of elevation at 50 degrees. So the question is, will our rock make it over Holy Cross's wall, or its 17.5 meter high wall? So knowing all of this information at the beginning, we can now create our initial and final and fill in all of the values for our horizontal and vertical components. So down here I have a triangle, and to find the initial and final vertical and horizontal velocities, I'm going to use polar coordinates. So polar coordinates are fairly simple to use. You have r, which is the hypotenuse, or in this case, the initial velocity of 25 meters per second, and r and theta as the angle of elevation. To find the y component of this triangle, you're going to multiply the hypotenuse, or r, or in this case, 25 meters per second, times the sine of theta, or the 50 degrees. And so we will get, this will now be down here, the y component, or our vertical initial velocity. So down here we have our x component. And to find the x component using polar coordinates, you take the hypotenuse, or r, or 25 meters per second as our initial velocity, and multiply it by the cosine of theta, so shown up here, which will give us our x component and our horizontal initial velocity. Alright, so now on to the actual problem. Knowing all of our initial components, and now we can start to theorize, up here. So knowing that the horizontal component will always be the same no matter what, since there's nothing acting on the horizontal force going across, we can now say the acceleration will be nothing, because there is nothing acting on the rock going horizontal. So it will be 0, meaning that the final velocity will be equal to the initial. Now, with the vertical component, we have the rock traveling up vertical at 19.15 meters per second. So this rock will be traveling up continuously, but it will be slowing down at 9.8 meters per second squared. This is the number for our gravitational pull on the Earth. So we have the acceleration here, and it will be so the rock will be vertically slowing down, and it will reach a maximum point, and then it will start to accelerate downward in a negative direction, or towards the Earth. And so as it accelerates downward, it will gain a negative velocity. Since velocity is a vector, it can have a negative component. So now to figure out if our rock will cross the wall. Using displacement, x bar is equal to initial velocity times time plus 1/2 acceleration times time squared. We can now say, since we want this rock to cross horizontally the 45 meters of moat, and then we want to know what the height will be at when it's at the end of that 45 meters, because we want to know if it will be able to cross that 17.5 meter high wall. So first we need to know the time that it takes horizontally for the rock to travel the 45 meters in the air. So using displacement, we have the 45 meters is equal to 16.69 meters per second, which is our initial velocity, as shown up here also in the formula, times the time, which we do not know yet, plus 1/2 acceleration times time squared. So, since acceleration is just 0, this will all just equal 0. And so we're left with the 45 meters is equal to 16.69 meters per second times the time. And so in order to get time by itself to solve for it, we're going to divide by the 16.9 meters per second. And dividing 45 meters by meters per second, we will cross out or cancel out the meters and be left with just seconds, which is what we want when dealing with time. So we get time, the time it takes the rock to travel the 45 meters and inevitably hit the wall or go over the wall will be 2.696 seconds. So now for the vertical part, or the vertical component. We know that the wall is 17.5 meters high. So we want the y component, or the vertical component of the rock to be greater than the 17.5 meters. So that means it will go over the Holy Cross's wall. So using the displacement formula, but modifying it a little bit, we can say that 17.5 has to be greater, or has to be less than the whole displacement of the vertical component. So we have our initial velocity at 19.15 meters per second times our time at 2.696 seconds plus 1/2 the